recording. Okay, testing. Okay, there we go. Okay. Test. Okay, recording. Okay, good. All right. Okay. Hello. Okay. We should. Okay. Okay. Okay, let's get started, guys. Hello. We're getting started. Thank you very much. So, hey guys. Hello. Calm down. Okay, so let's get started with today's class. First of all, I want to give an advertisement. So, you know, we have the site www.sdba.info. So if you go there, oops, what did I do? I just closed it. Oops, went to the wrong one. Oh, what did I do? Sorry. Okay, I'll go, sorry. What did it do? Crawl. Okay, so if I go, forget that. So we go to www.sdba.info. It has most of the stuff you need to know there, but if we go to Basic of C Programming, one thing that I don't think too many people have used this semester is the recordings. Okay, so if you don't understand anything, you can check recordings. So the recordings tab allows you to, this will go to a YouTube playlist, which contains everything, but this will give you different ones, like each class, going all the way up. And after this, like classes we haven't had yet, like lesson 3, array lesson 1, lesson 2, lesson 5, flow walkthrough, arrays and loops. So basically, these will be from last year. So if you want to go ahead, you can go ahead of the course. The idea here being that you could always complete milestone 6 anytime you want, because all the view graphs are already here to work through by yourself. Okay, so if you don't understand anything, look through some of these milestone walkthroughs. Previous milestones, milestone 3, another walkthrough. So a milestone 5 walkthrough, milestone 4 walkthrough. So these milestone walkthroughs hopefully can help you to get the ideas that you may be missing. Okay, so we'll just move that out of the way now. All right, so that's recordings. So each of those recordings are posted on YouTube. So if you click on, say, you wanted to worry about this week's class, you just click on from this week's class last year, and you can basically go through and sort of go through as quick as you like. It's an hour and 22 minutes, but you can quickly go through the whole class from last year. All right. Okay, so that's the end of my advertisement. 广告结束了. Okay, last week we took up milestone 3. We talked a little bit about the theory. We talked about reviewing root, the pointers, and then we talked about optics and the decision making. We started with the flow. This week, I want to start by just taking up milestone 3, the basic coding, the cylinder, because I noticed this will be the last time I actually walk through a milestone 3. You should have, hopefully at the end of this class, you'll have finished it. And then we'll go through milestone 4, walk through. We'll review conditional flow, and I hope in the first hour we'll be able to finish talking about how we split code into 4 different codes. Question? You guys have a question? Are you confused about something? Yes, no? If you have a question, please ask. Okay? We're very happy if you have a question. Okay, so, all right, please ask if you have questions, okay? After the break, we'll talk about how we do repetition in C, the second flow structure. Then we'll work together in optics 1. We'll do milestone retry, and then your homework is to add repetition to the gravity program. Okay? And that will put us because I think we have 2 more this week. We have a couple more classes before the final exam week, which will still be milestones. Okay. All right, so let's get started with the take-up. Walk through. We'll walk through milestone 3. I think this will be a review for some people, and other people hopefully it'll correct what you were doing. So if we remember, the milestone 3 from last week was, let's see, open the file. Here we had milestone 3, I think. It was, this is correct, this is the milestone from last week, right, Johnny? Is this the milestone from last week?
I think milestone 3, no.
That's not milestone 3?
I think that's the last week milestone 3.
This one, which one? Okay.
Just calculate it.
Oh, hypotenuse. It was hypotenuse. Pythagoras. Okay. Okay, Pythagoras. This was the one from last week, right? Very simple one this time, last week. Okay, so this one will be more challenging this week. Okay. All right, so we wanted to calculate this, so let's start to walk through it. Okay, I'll open Notepad. Okay, and I should also start with okay. Okay, so if I'm going to do, I'll probably start with okay, Get everything set up. Okay, let's start with our UML. Okay, I'll just shrink that down, shrink my UML up a bit. Okay, start symbol, end symbol, actions to do. We basically need three, it's very simple UML, this one, right? You're going to need a function for input A, B, C, I'll call it C2 equals A times A plus B times B. Okay, that would be my, probably I can put it in 2 lines, and print A, B, C. Okay, and I just connect it with that arrows. Okay, strong, 1 arrow. Two arrows. 3 arrows. And 4 arrow. Okay, so that would be basic. That gives me my outline for my program. This program. I can look at that. Let's get rid of that now, and I'll go to my C. Okay, file, save as. I'll just SDBA, this PC, SDBA, and I'll just py.c, okay? All right. What does it tell me I want to do? And okay, I need to use, okay, Pythagorean theory. You should prompt the user for input, okay? Let's write our let's start our program then. We've already got our UML. I start with a comment line, Pythagoras. Okay, after our comment line, then I'm going to need, let's do our main first. Okay, integer, main, void, and what steps do I need to do? I need to prompt the user to input A and B. Okay, let's use get flow prompt for simplicity. Input A. Okay, so I prompt the user to get A, and okay, this is kind of huge. Okay, shrink it down. Okay, so A equals, okay, next I want a B, so I'll just copy this. B equals input B. Okay, then I need to calculate C2 equals, I would say calc C2. I need A and B, and then I'm going to do F print F. Where am I going to, okay, F print F, and I put standard out. Since I'll use that, I'll put %LD. Are they floats or, it doesn't say whether I want floats or integers. Okay, I'll just do integers. Okay. A equals, B equals, C squared equals, and it's going to be A, B, C2. And that's the end, return 1. Or return 0, whatever you like. Probably return 0. Let's return 0. Okay. Okay, so this would be, we've now got the main program. We're using 3 functions, so I need the prototypes for this one. So include j in live.h. Then at calc 2 I'm writing myself, so I'm going to say long calc C2. It needs a long A, long B. Okay, and the third one is, my third function is f for net. So include .h. And okay, so I'm getting the function definitions from here for this one, function definition for this one from there, and so I just have one function to make, this one. So long A, long B, get rid of this. Okay, C2, okay, let's say long C2, C2 equals A times A plus B times B, okay, and then return C2. Okay, so I've been calling the function, I'm giving it 2 longs, I'm doing my calculation, and then return it. Okay, am I missing anything? Okay, check. Have I declared my variables? No, I have not. I've declared, initialized, used. Okay, what about A? Initialized, used, not declared. Okay, so I'm going to have to declare him. A, B, C2. All variables are now declared. Program is saved. Okay. We will now basically go to the okay. Okay, let's now compile it, link it, and run it. When you're compiling, linking, and running, it's sometimes useful to just, first of all, just clear screen, CLS. If I type CLS, I will clear the screen, so I don't have to have anything junk in the screen. Then GCC minus C minus wall py.c. Oops, error. Okay. I look at the error and I say %d expects type int. %4 has long int. So it's saying, okay, I missed my L. Okay. Correct. Okay. That's one problem. Okay, let's see. Okay, expected. Okay, am I missing something? Where am I missing? 16-2, return C2. It does not like it. What am I missing? Let's look. Okay. Oh, this guy has no partner. Okay. Okay, so I'm looking at 16 and seeing what's wrong after C2. And then I'm seeing, okay, there's no bracket. Okay, let's try again. Okay, works. GCC minus O, py.o, jinlive.o, and, name of the file, p.exe. Okay, plus it. Okay, and P, A2, B2, C is 8, right? 2 squared plus 2 squared equals 8. Test another number, 1, 1. Okay, 1 squared plus 1 squared is 2. Looks good. So basically I've done 2 test cases. All right. Okay, our next one that we want to walk through, I'll close this, Don't save. I don't care about that guy. We looked at quadratic, right? Quadratic is the one we did last week, right? For milestone 4.
What?
Which milestone 4 did we do last week?
Uh,
Quadratic?
AX plus B, BX plus C.
That's quadratic. Okay, thank you. Okay, all right. Let's go look at the quadratic milestone. So back to. Okay, milestone. Okay, let's look at what we've got here. Okay, if you remember the question. Okay, this is the equation. We're solving for ax squared plus bx plus c. We're using, as we look through, we're seeing using standard input output and math.h. We use math.h because we want the mathematical formula for square root. Okay, and we created our own function, solve quad. Okay, which takes 3 number and it has, okay, and there's our main program, and now we want to try to understand what's going on. We want to know what the diagram looks like at line 23. Okay, so let's look at the solution. Okay. All right, let's show. Come on, show. Uh-oh. I think I have to close this other one. Oh, don't crash on me. Thank you. Okay, let's try again. Okay. All right. So let's look at what happens here. Okay, as we go down. This is the code I put here. So as we start, first of all, we created main, right? Main has a number of variables. I declare a container of type double, and put 1 in it. I declared a container of type double, which was B, put 2 into it. I put a container of type, again, another container of type double, and I gave it the name C, put the value -3 into it. I declared another variable R1 and put 0 into it. Okay? I put R2, I put 0 into it. Now note, you know when I try to put 0 into a double container, I cannot put 0 into a double container. Okay? I can only put a small number. So what actually it puts in, the computer puts in a small number, like it would be something like -10 to the -23. Okay? It doesn't put in 0. Okay? All right, and I create one long called solution and put 0 there. So this is at line 18. Okay, and at line 18 we are also calling function solve quad. So solve quad is called at this line. So it contains, what does it have? It prepares a double called A2. It prepares a double called A1. It prepares a double container, variable container for A0. It contains a double container that's going to hold an address and calls it PR1. And a double container that's going to hold an address, PR2. In other words, 2 pointers. Okay, so this is what this contains. And then this line, line 11, does the transfer. The value in A is copied into A2. The value in B is copied into container A1. The value in C is copied into container A0. The address of R1 is copied into container PR1, so that makes the pointer point to R1. The address of R2 is put into container PR2, so now PR2 is pointing to R2. Okay, this is what's happening at line 18. Now let's move down a few lines. Okay, we move to line 20. Line 20 basically does the calculation. It takes A1 times A1, A2 times A2, A2 times A0, carries out the subtraction, and it gets 0.16. Okay, e to the 2 or 16. Now we're going to see these two. Okay? Next line, we move on. Come on, move on. Hey, okay, oh sorry, okay, so basically what we're doing is now updating these two, PR1 and PR2 get updated. Okay, so PR1 had 0.1. The next line updates that, right? It does the calculation, A1 plus the square root 2 over 2. It ends up putting in 14. The next one puts in 18. Okay, goes to R2. All right, 14 and 18. I think maybe I used different numbers this year when I did it with in your question sheet. Okay, so and that basically is going to complete what everything looks like at line 23. Okay, these guys are in here. These guys are in here. If we continue on the program, then this function will disappear. Okay, we return. And this will be after line 23. When we return, we will then put 2 into solution. Okay? That basically then completes this code. So in the future, possibly one of the milestones will be doing the complete quadratic equation. Okay? Okay. All right. Okay, and all right. So we've moved on our examples. Let's now review conditional flow, and then we're going to go into the optics issue, multiple files on page 39. But first, we're going to review. Okay. All right. The key sequence. Okay, the different ways in which we can go through a code from beginning to end. Sequence, decision, repetition, and parallel. Sequence, each step after step. Okay, decision. The function starts to run, and based on the data, only part of the function is used. So that's what we've looked at so far is the decision, right? Only one, depending on a situation, it has to be true or false. The other part is not used. Repetition is what we're going to be learning today. Okay, in which we repeat a statement many times. It's actually quite amazing. Only 3 different structures can be used to do everything. Anyways, kind of cool. Okay, so these are the 3 constraints. Okay. All right, so we looked at this example. Quadratic equation. Why we need a condition. In other words, if b squared minus 4ac is less than 0, if we want to take the square root, we have to reverse it and do 4ac minus b squared. And then because it's an imaginary number, we have to change the signs. And the optics code, which we solved, was the other problem we tried to show when we needed a decision. So we looked at the optics code. All right. So that was a crucial thing looking at. Let's go look through optics code. We'll review that. Okay, I'll zip back to my optics code. Okay. So we remember what the if we... Okay, we showed how the program... Okay, this makes sense. The person's at the focal point. Okay, x0 is h1, the length of the lens is 5, he's from the 5, he's right at the focal point. In other words, that's where you put your light bulb for your headlights on your car, right? Because you want the light to be out parallel. So this is the correct spot for a headlight, an LED light here, the lens here, focusing to far distance. Okay, good. Now, if we use the existing code and we put the person on the other side, and we used our code, basically what happens is we find out the X's, the image is going to be here, right? We showed that calculation using our code. Now that's clearly wrong. Okay, so what it should be is what it should look like, the exact opposite, right? It should be at negative infinity. Okay, that would be the right answer. So we have to fix our code. And so when the calculation is wrong, we basically summarize. When the object is to the right of the lens, i.e. O is less than 0, then I is calculated wrong, and therefore xi and hi are wrong. So I is wrong, therefore hi, xi is wrong, therefore hi is wrong. So we have to fix the calculation of I, then we should be able to have these guys calculated right. Okay, so it's this formula we've got to change. So we can focus in where we have to change. This has to replace this formula. Okay, there's our calculation again. We need to think about why it's wrong. That's what we have to think about it. O times F is negative and O minus F are wrong when 0, O is less than 0, right? You can see minus, okay, so this is incorrect. So it should be at infinity. Both these things, Fi and O minus F, are both wrong. Correct would be O minus F 0, F times O basically 25. Okay, so what do we want to do? It seems we just have to change these numbers. So we can then, if we put a minus sign, we can make this correct. O plus F minus OF. And now, if we're on the other side of the lens, the calculation works correctly. If for people on the right side of the lens. Okay, so right side of the lens is this formula, left side of the lens is this formula. Okay, so when O is less than 0, our condition is O less than 0, use this. If O is greater than 0, use the conventional equation we've learned already. Okay, so O greater than 0, O less than 0. So in this case, O will be less than 0. All right. So we just modify our UML first. So that's just this one spot in the UML. O greater than 0, do this. O less than 0, do that. Okay? And if O greater than 0, do O times F, O minus F. Else, do minus O minus F, O plus F. That's just a C code we need to switch for doing an if. So we then rewrote our C code. We modified this code last week. This equation lens is the only place where we wanted to change, because we don't want to change anything else in the code, because it's only this line we need to change. And we replace it with this sort of a code. Okay? Double O, double F, double I, same as before. But if O is greater than 0, do what we always did. I equals F times O divided by O minus F. If otherwise, we're going to have to use the modified equation. I equals minus F times O, O plus F, return I. Okay, so we just have to make that minor change. And we then run the code and check it. And let's walk through the code so you can see how it works one more time, so we can do that and then move on. Okay. All our function prototypes are all stuck up here. This time I'm getting one from standard input and output. That's the printing one. And I'm writing all these 4 functions in my file. And now I've got main starts. This is where the program starts. I declare all these variable containers, F, H, O, I, XO, XL, XI, okay, are all contained. I call getOpt, that function that we wrote earlier, and gets XO and H. I call getOpt again, and I get my XL and F for the lens. My little function to put it onto the coordinate system, O, from my coordinate system. I use equation of the lens now. This is the big part now, equation of the lens. O comes in at minus 1, minus 10. F is 5, okay. We make containers to hold it, O and F. We take the O and F from the main program, take containers, create another container I, and then run our check. Is O O greater than 0. No, it's not. So we're going to jump down to the else. We jump down to the else and do the calculation. Okay, in this case it calculates minus 10. Okay, we return I. Okay, and calculate our magnification. CI gives us where it is going to be again, and F print, and I went up printing something like this for this input condition. minus 10, XI 0, H 5, because I haven't formatted it at all. And return 0. Okay. I hope that should be pretty okay. So that was our, now oh shoot, where did I get my function? We'll get back to my code again, and we are now at 150. Good. Okay. Okay. So let's start. Okay. Now let's move to optics section 7.2. That's page 39 in your book. Okay. We're going to page 39 in your book. All right. And we're going to try to do this together. And starting on that on page 39. Okay. 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 We'll do this in basically. Okay. Okay. We're going to run through it very briefly before the break. Then we will break and go to Google Meeting. Okay, so we'll work through it together with Google Meeting, but I want to preview it right now. So you can think of this as a preview for what we're going to do right after the break. I want to go through it. Basically, we're going to go through it twice. Okay, let's see if this is working. Yes, it is. Great. Okay, good. All right. So optical ray tracing. Now, I'm talking now about large project maintenance. Okay, splitting into multiple files. Oh, I should bother these guys for a second. Okay, sorry. You have your handphone. Can you need 5-minute video if they want? Your department wants 5-minute video. Of the class with me. So please take a picture with your camera. You have your camera and take video. Okay? So we need to do that. Yeah, just the classroom, be in the classroom and anything else. Okay, all right. So anyway, so we're moving to optical ray tracing, and oftentimes as a project gets large, you can't keep just one file. You need to start to split your program into small files. So the part you're working on, or if other people are working together, you don't want to put everything into one huge file. You want to work with lots of small files. So that's what we're going to be talking about now. Okay? So this is our motivation. If our code is long and the functions we are calling are static, i.e. they never change, then we can start to split them into smaller files. In order to split into smaller files, we basically have to have a header file, we need a main function file, and then our smaller files. So in this case, we're going to try to split our optics program into 3 smaller files, including a header file, the main function, and the static function. So you can see on the right of your screen, you can see all the whole program right now. It's getting a little bit long, so we're going to split it into 3 files. Oops, sorry. Okay, so this is basically going to be the architecture for our split. Okay. We're going to have to create a header file to hold the 4 functions we're going to split off. We're going to split off the function CO, equation lens, C magnification, and C psi. We're going to split those off. So that's those static functions. We're not going to be changing anymore. So the functions at the bottom, I've noticed static functions. I'm going to put them into a file olib.c. The main function, I'm going to keep, and I'm just going to call it o_split.c. The header is the third file, a .h file, which is going to hold those three .h file, the three prototypes. Okay? So you have that, understand that, that's going to be the architecture. All right. So this is what the header file is going to look like. It's a very short file. It contains the prototypes of the four functions we're splitting off. C0, equation lens, CMag, and CSI. So each of those are put here as a prototype. The second file is your main program. In my main program, I've decided to keep one function. You can see I've kept one function, get off, because I'm going to be changing that function later. Because it's a very, there's better ways to write the function. Okay, so I'm going to change it later. So I'm going to keep it with the main program. And you can see here, there's a few key things in this file that I should mention. Look on the fourth line, I include olib.h. In other words, because I've got the function calls, right? I've got the function calls in the main program, I need to have a function prototype. So I'm putting the function prototypes are found in olib.h. So the compiler will put those into this file when it compiles everything. All right, so this is what the main one looks like. And finally, we have the library functions that I'm going to say the functions I'm never going to change. I just put all the C code in the third function. Since these functions are all working properly, and I will not change them again, I want to be able to forget them. So I put them in a separate file. I won't be looking at these again, I'll be totally forgetting them. And we can, once we've got them into 3 files, we can compile, link, and run. So basically I have to compile both the 2 C files independently. So first of all, GCC minus C minus wall, the main function, which I call split. Then I have to do my olib.c, and then when I link them at the end, I need to put the 2 object files together, and that into my executable file. Okay? In the past, you've done that with jinlib, right? You've added that at the end if you were using my functions to get input and output. Okay, so we'll now take a break, and we're going to we'll go and start the next part of the class on Google Meeting, okay? And we'll walk through it together. Okay, so please break for 10 minutes. Okay. I didn't mark them like that. The TAs have them. But I give them all to the TAs, so the TAs check carefully. Remember, you give them to me, and they can tell you what's wrong.
You said that you will check it later?
Yes, I did, so the TAs check it, not me. Yeah. Oh, right, okay, thank you.
To this time.
No, there's no numbering,
No number.
and it's not a complete tree.
Okay.
So,
I'm going to change it.
yeah, so it's not a complete tree and there's no numbering. So you see, this is a line, you can't do this, right? Okay, no, so, yeah.
Do I need to take a picture and...
No, well, right now it's 2 points out of 6. If I mark it right now, it's only 2 points out of 6 at maximum.
I need this time I need to
Upload everything. There's also you also have to send by email. Right, it says here. Everything, yes. Right here. You have to send everything by the way it says here. Okay. All right, Stephen. Thank you, Steve. No, that's not it.